Hi students, today we will discuss about sandwich theorem, also known as squeeze theorem. So coming to the statement, if an, bn, cn are three sequences such that an less than or equal to bn less than or equal to cn for all n belongs to natural numbers, and what he has given, limit n tends to infinity an equal to l and limit n tends to infinity cn equal to l. So both sequences approaches to l, then we need to find that limit n tends to infinity bn equal to l. Okay, so given that an, bn and cn are three sequences, okay, and such that what has given, an less than or equal to bn less than or equal to cn. So this is a very important condition, and for all n belongs to natural numbers. Now, so from the definition of limit of a sequence, so what we have, for every epsilon greater than 0 and there exists, so m1, so here I am taking m1 and m2. Because here we have two limits, so m1 which belongs to n such that, so for the first sequence I take modulus of an minus l is less than epsilon for all n greater than or equal to m1, where n which belongs to natural numbers. Clearly, if we expand this, what do we get? Minus epsilon less than an minus l less than epsilon, and finally add l to the inequality. What do we get? L minus epsilon less than an less than l plus epsilon. So this is condition number 1. Again, similarly, so for every epsilon greater than 0, there exists m2 for C2, m2 which belongs to n such that modulus of cn minus l which is less than epsilon for all n greater than or equal to m2, where n which belongs to natural number. Now I'll expand this. What we get? Clearly l minus epsilon less than cn less than l plus epsilon. So this is condition number 2. So from the given data, see here, an less than or equal to bn less than or equal to cn. So clearly, so an is lesser cn and in between them we have bn. So for suppose take a number line, so we have an and then cn. Clearly from this one, an is lies in between l minus epsilon to l plus epsilon, and cn is also lies in between l minus epsilon to l plus epsilon. So I can write like this. So an which is less than cn, so here l minus epsilon and here l plus epsilon. In between them we have bn, that is here. Okay, see the number line. So an is less than bn less than cn. So these are all in between l minus epsilon to l plus epsilon. So from this number line, see from 1 and 2, and from this number line, you please understand that, so an is less than cn and these two lies in between l minus epsilon to l plus epsilon. So that from these two and from this number line, we are clear about l minus epsilon is less than an and less than cn and less than l plus epsilon. So this is condition number 3. and we have an less than or equal to bn less than or equal to cn. For suppose if it is 4, so from 3 and 4, what we write? Clearly L minus epsilon less than an less than or equal to bn and less than or equal to cn and less than epsilon plus L. So that is L plus epsilon. So please observe that. So an is less than cn, in between them we have bn, and these are all satisfying condition. An less than or equal to bn less than or equal to cn, and these are all in between. For suppose if you take this one as f of x or something, whatever it may be, and this function and this condition lies in between L minus epsilon to L plus epsilon, which means that so bn is also lies in between L minus epsilon to L plus epsilon. It is very clear thus from this figure. So bn also lies in between L minus epsilon to L plus epsilon. So what we will write? So L minus epsilon less than bn less than L plus epsilon. This is what we get. So what is all this? What we get? Clearly is nothing but subtract L minus epsilon less than bn minus L less than epsilon. Now take modulus. What we get? Modulus of bn minus L is less than epsilon, where n is greater than or equal to m, and where n which belongs to natural numbers. Clearly here what is m? It is a maximum of here m equal to maximum of m1 and m2. So why are you taking m1 maximum of m1 m2? It's very clear that clearly, for suppose if it is m1, if it is m2, so we take the maximum of m1 m2, which means the very greatest value in between these two. If you take the greatest value, then it is very closer to the approaching limit. So that's why I take the maximum. Why? Because if you take the maximum, clearly it is very closer to the limit. So that's why if modulus of bn minus L less than epsilon, which means that clearly limit n tends to infinity, so bn is equal to what? L. This is what we need to prove. Thank you.